Well, this happened really quickly. I just ordered this a couple of days ago, and it's here already. This is what it's supposed to be. It's a flyback transformer. It's not the exact right transformer, but I got it from Moyer's in Moyer Electronic Supply. They have a pretty good size, maybe one of the best inventories of vintage TV parts, and I sent them a big list of what I was looking for, some cross-reference numbers and model number and the chassis number and all that, and they had one that was on my secondary list, and it was not exactly the one that I was hoping to find, but it will do the trick, I think. We have to do some modifications to it. But let's just see what we have first. And I also ordered a couple of capacitors to be a part of that modification. Yes. So this is a Thordarson. It's a flyback, the 323. It is a direct replacement for the, for a variety of Zenith flybacks, including the 72520. I believe that this can be made to fit into this chassis, because I think that really the significant difference is that with this chassis that we're looking at, this 16Z7C50Z, they introduced a horizontal efficiency coil. There's a couple of additional things on the flyback. But, oh, what a beauty! A new old stock. Thordarson. Oh, something got bonked. Uh-oh. We'll just pretend we didn't see this. And this is our focus voltage, and this is our horizontal positioning control. Beautiful. Look at that. Focus rectifier. This is our voltage divider. Boost voltage should be here. The other boost voltage should be here. And then this is the boost rectifier. And then this would go to the focus lead. At the picture tube. What's nice about this particular transformer is that they have leads coming off of the primary, because the other one, they're just lugs, and the wires inside of the set is they're hard and brittle, and by the time I get them detached, they're going to be too short. So gotta take a look at that. This is very interesting. There's another resistor that is included in this kit, probably for the use on other chassis. Let's see what's Thordarson Meisner, Mount Carmel, Illinois. Nice. And our data sheet. Ooh, I like this. "22 picofarad at 6,000 volt cap." And if you're curious, it's not a cheap hobby sometimes. But that's the cost of bringing back a piece of history. Extricate this from the chassis. So I'm just going to go backwards from where I started, or where I completed this. So these two would normally go to the wiper of the horizontal position. I'm just going to snip it here. Snip. I'm going to unsolder this one, pin 2 on the Molex connector, and pin 3 on the Molex connector, which goes to boost. I'm going to try to unsolder, 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 I think. And we'll pull it out, and we'll see what we have to do in the back. Yeah, these wires are brittle and hard and too short. All right, this is back to where we were a little bit ago, right? And we don't really know where this was arcing. I hope we would find some forensic evidence in here, but do some snippage. Just leave a little bit here. And we're gonna need every millimeter of wire we can save here, I think. This black wire, is that the next terminal over? We do not cut that one, that's part of the transformer. And then we have the yellow one. Let's see here. Where? What am I trying to see? I'm trying to see where that yellow one connects. Let's look at this new Thordarson. Thordarson! Here we go. So yeah, the green, green, red, black. Oh, be careful when we cut the black wire, because one goes somewhere else and one goes here, and then the yellow one is right there, the next one. So that's what these leads are. Green, red, black, yellow. They go to the convergence coils. Okay, one more wire to cut. This wire. I believe this wire. Because the other wire is part of the transformer, right? Yeah. Alright, let's go here. There we go. I think we succeeded. Okay. Well, that is, I believe, oh yeah. We get this that comes out with it. Oh yeah. So what we have to do is unsolder. We have to unsolder this high voltage anode lead. Do we? Well, only if we want to reuse that wire. I have another piece with a cup, but this is just going to be in our way. What do you think? Maybe we snip this also, and that way we can remember, because we're going to have to snip, or resolder. Yeah, okay. You might try to unsolder this. But you know how this goes. It's always wrapped around several times around the lug, because when they built it at the factory, they didn't want it to come unsoldered, and they really believe that you'd never have to do this. So, right. Okay, we're gonna snip the red wire. The red wire. Cut the red wire. Cut the red wire. Okay. And we're gonna pull this off. We will get the other one. We'll get the socket off later on. That's it. Look at that. You know, it doesn't look nearly as bad as I'd have thought this was going to be. I thought this would just be completely baked. Forensic evidence of complete destruction. But it's just dirty. It's just high voltage goo on it. I don't really see where that arcing was coming from that was lighting up this rectifier. Granted, I didn't do the best solder job on it. Maybe it was arcing from ground to those points, maybe. The back. Is this phenolic conductive now? Possibly. Okay, let's get it on the bench. Well, this is quite a collection of flyback transformers. And this is what we just took out. And this is that stand core we've talked about before. And then this is our brand new old stock flyback from Thord Arson, the 323. And I think this is the one that we're going to use. And we have to do some modifications to it. I'll talk a little bit about that, and I'll kind of show you why this one really can't be modified. Not really, for what we have to do. So if we go back to our original flyback, I thought we did a pretty good job on replacing the controls. I've checked continuity on this whole transformer, and everything is there. Done some ring testing and trying to measure across the coils from the tap points to another tap point, and all the taps off of this transformer winding have continuity. And you can see that there is a lot of corrosion on here. This green corrosion stuff. But and I do not know how many molecules of copper are actually hanging around in some of these places on this transformer. These are pretty thin wires, and there is a lot of corrosion, so that's why this one broke off and I had to solder it. It was just corroded to that point. So that's the unknown in this. That's one of the unknowns. So on this original flyback, this 150 picofarad capacitor, it's cracked on both sides. So you can see that it's cracked there, and you can see that it's cracked here as well. So I would have to assume that that has something to do with this arcing. But I still don't know the mechanism of why it was doing that. That was Bizarre. But clearly something's been going on for a while, and that was the cause of why this high voltage system burned up. But you can see all the corrosion there at that tie point, and yeah, there is some evidence of arcing and ugly stuff, because it wouldn't make sense otherwise. I haven't given up on this flyback. I ordered a 150 picofarad cap of the correct dielectric. This would need to get, so replace this 22 picofarad capacitor, and this checks out fine, the resistor. It's a 47K 3 watt power resistor. We replaced these two controls, and I think they're fine. I'm gonna have to replace these two 22 megs. These are 22 megs at 10% at 2 watts, because they're both under value, off much more than 10%. This is correct. This is a 68K resistor, and this one, well, these two selenium rectifiers, I still haven't fully figured out how to test them, actually. So we'll get into that too. And then this plate cap this wire has to be redone. I thought I might be able to cut it off here and resolder this cap on it. I don't need much, but as it is here, when it broke off, it's too short, and we saw that we arced right through this insulation, so this is not the right wire really. So what I thought I might do is clip it off at a clean spot, use another layer of heat shrink, and solder this back on. Replace, probably replace this, replace that, replace that, replace that. So I haven't given up on this. I have some of that fancy new tape. I've got a stack of different sizes of this high temperature tape, but I thought we could wrap up some of this here. That insulation is busted up. You know, this would be a clean it up kind of job. Clean it up, get this carbon off, get that busted capacitor out, clean up the carbon there, try to clean up this corrosion. And then I really believe that this might be part of the problem also. On the secondary of these transformers, there are 2 wraps of wire, and then these 2 leads go to the filament of our high voltage rectifier. And these wires are stiff, but I suspect, and it's a pretty common problem, that these are arcing to chassis. So I got a stack of some 30 kilovolt DC wire. I think this is silicon insulation, so it's flexible. So I believe that this horizontal sweep transformer can be rebuilt. I have nothing to lose by trying, other than just a whole bunch of time. So that's on the menu of things to do, although that's not what we're going to do first. I'm going to use this. We're going to replace, we're going to make the modifications to this flyback transformer, and we're going to replace it. And we're going to get into, I'll show you why I think this one couldn't be used to be modified. So let me get the schematic out, and I'll show you what I'm thinking. So back here at the Rosetta Stone, we have the Zenith schematic for what we're doing. This is the horizontal sweep transformer, and then we have the SAMS version of the same circuit, just drawn a little differently. And I have been using these points here on the SAMs that demonstrate these tie points I've been looking at that, but I think we're just gonna, now that I've stared at this long enough, I really kind of understand the circuit. So what we're gonna do is on this Thor-Arson flyback, we're gonna add this 47K 3-watt power resistor and this 22 picofarad N1500 dielectric cap. They say it only needs to be a 3 kV. I have 6 kV caps, but that's fine. And but this is what's unique to this flyback on this design, is that if we come off of the horizontal output tube, the plate cap, that wire travels to this point here where that 47K resistor ties in. So from that 0.5 to the plate cap, you have effectively 0 ohms. So on the stand core, we don't have that option because our plate cap goes directly into the windings of this transformer and then goes to a tie point. And what we really need is what Thor-Arson has provided, which is the plate cap comes across here and ties to this point. So at this point, you still have a resistance of 0 ohms directly off of the horizontal output plate. And then it goes into the windings from here. So we have a point we can tie on to. And what we are going to need to do is to move this tie point, or move the lead of this focus diode to this point here. This is a tie point only. It's not connected to a winding. So this lead comes to here. We move this lead to the tie point. Between this point and here we have the 47K resistor, and then from here to 0.7 here, this white lead, we tie our 22 picofarad cap. And I think essentially that is all the modification we have to do to make this work on this set. The only other thing is this resistor. This is a 27K. On the original, this is a 68K. So gonna have to come up with a different resistor for this point. So we change this and we add this 47K, we add this 22 picofarad, and we should be good to go. So these two components, resistor, capacitor, resistor, capacitor, and then this lead goes to this tie point also. And we can't do that with the stand core because the plate cap goes directly into the windings here. So we'll keep this one for our other X-year chassis, and this one we're going to get to at another time. So in the book they talk about this modification, high voltage and focus tracking. And they talk about that it was implemented in the Y year, so the production year of 1968, and this is the Z year of 1969. So this series of color chassis incorporate a focus voltage filter circuit for optimum tracking between high voltage and focus voltage. And the circuit components are a 47K 3-watt and a 22 picofarad 3 kilovolt capacitor. And they're mounted on the sweep transformer, just like this. And talks about what it does. Normally a pulse taken from the top of the sweep transformer for focus voltage rectification contains a ripple due to the normal ringing voltage in the primary circuit. So this filter eliminates the ringing and keeps everything in phase. So we're gonna make that change and get this back together, I guess. I had decided early on that I was going to get this set to work, at least get the high voltage working before I pulled the chassis out. Because getting the chassis out of here, it looks like it's going to be a bear. However, now that we have taken our horizontal sweep transformer out, I think there's evidence here of arcing. Yes, I would say most definitely. So that is probably a big part of this trouble with this high voltage in the set. And these wires that we snipped, they're somewhat pliable still, but a couple of these are just too short to work with. I didn't want to take the chassis out, but I think this is a mess to get at, and you really can't, you just can't get in here in a satisfactory way. And I think if you took the chassis out, we can give this thing a much better inspection. There is a lot of carbon in here, typical high voltage goo. So I think I'm going to pull the chassis out. And I have to be very careful. This is still really iffy. And we have to get to the bottom of this resistor that is cremating itself. And I thought I would change this capacitor too. And so pull the chassis out. We can get at some of these components in a much more efficient way. We can do an actual visual inspection of all this stuff here, because we really don't know. We don't know why we had that arcing in there. And we're going to put a nice new flyback in here. So we are going to clean this up, give it a great visual inspection. Well, I'm impressed that Zenith had really gotten it all together with connectors by this production year. It was very easy to disconnect things, and I think it's very clear where it all goes. I did take some pictures and I marked things, but under no circumstances am I allowed to smash the neck of this picture tube when I slide this chassis out. So I'm going to put these bins down here and see if I just got something to slide it onto, and then I can roll the cabinet a little bit further back and pick it up. And once I get it up, I'm going to put it on top of the cabinet, so the cabinet becomes its own operating table, I guess. Super good. She's free. Okay, the chassis out. Chassis out, and did not have any problems. We were very good to the neck of the picture tube. And yep, it's dirty for sure. Looks like something that was sitting in an abandoned house for a while. But this is going to allow us the ability to really get in and inspect it. And taking the chassis out, disconnecting it was, as I said, it was really not difficult. And I marked things. I took pictures. It's all good. The degaussing. These are the DGs. The DGs. These are the DGs. I gotta mark these. The degaussing coils. Red wires. Alright, just gonna mark degaussing coils. What is this? Speakers. Alright. Okay, we got a lot to do. I did also want to show you this other ridiculous thing, this particle board, chipboard, that this beautiful cabinet was made on top of this horrible chipboard, and it just continues to fall apart. This might be the weak link in the whole cabinet. The can says that I should put 3 light coats on, but I put on 1 heavy coat to start with. This stuff just gets absorbed right into this. It's pretty weird. So in the meantime, I'm going to work on the chassis. Clean it up. I got some acid brushes and other things, so we're going to do that now. Took the old shop vac and put the hose in the backwards direction so it's blowing out. And it's got a lot of oomph to it. Check this out. Check it out. So yeah. Got to be careful, of course, but I want to make sure. I left the tubes in because I wanted to keep the dirt out of the sockets. Even the transistors I left in for that same reason. And it's good. I think it's looking... This is a level 1 cleaning. Brush and air. Brush and air. And this is coming along. This is that first coat, and it's almost dry. So we're going to put another... Well, we'll give it a little while. Put another coat on. So we're going to continue on with this. Going to get at the high voltage cage, and then we figure out how to get at the bottom. I was also just knocking this rust off of the... It's really weird how this it rusted pretty badly around these grommets that had the high voltage wires coming out. I cleaned it up with some navel jelly. Well, I wiped out the inside of the box and cleaned up some of the wires. It's looking pretty good. These would have been the 2 filament leads for the high voltage rectifier. And you can see this. It was definitely arcing, for sure. And that would have definitely killed the high voltage in this system, because once the rectifier is conducting, there's actually 25,000 volts on those 2 filament leads as well, because the cathode is common to the filament. So this high voltage arcing is really a problem. I figured that at the time, but we needed to go through this process. Well, this has actually worked out pretty well. It really has. I mean, I couldn't have done this before without all this stuff flaking off. I still don't know how. I don't think this is a permanent solution, but just gonna glop 1 more or 2 more layers. I had this brush in a bag overnight, and it's not really a brush anymore so much as it's like a spatula or something, but that's all right. This is not precision work. This is just brute force. This is the purple wire that goes to the high boost point. I had put a little bit of heat shrink on it just as a just in case before. So this point here on the screen controls has all of the, this point right here has all of the 1300 volts of boost that gets distributed to each of the 3 screens inside of the CRT. And this is something we do want to pay attention to, is whether or not there might be any arcing between some of these wires. You know, there's a lot of heat in here, that's for sure. All right, let's just take a look at this here. Just a Q-tip with some alcohol on it. What's that? No, not that kind of alcohol. Let's see if we can get in there closer. So this wire, the white with red stripe and the purple, come up into this bundle and goes up to that what I'm calling a Molex connector that is on the side of the high voltage box, and then this goes up into the deflection yoke. I think this is the extent of the rough handling here. We don't want to, but it's looking good. This one, I still don't know what we're gonna do with this one. I don't know. I've bumped my hand. Oh, nuts. Hold on. This is the problem. You can see it. It's just boogered up. We've got to do something about this before we do anything else. You know, let me get the meter out. Let's just check some continuity. Let's see if there's continuity there before we do anything to it. But from pin 6 to one side of our 220, that's it indicates continuity all the way through that coil. So take a look at that. All right, so I got the old meter here in beep mode, so you'll hear it. And so this junction here, right here, that's the 0.01, that's the 220. So we should have continuity between here and here. Yes! So that's good. That indicates that we have continuity through the whole thing. So, and then the other point would be here. That's the primary of it, and then this would take us all the way through the whole coil. So we have continuity in that coil. Yay, okay, good. Oh, I think we did okay with our epoxy job. I did glop a lot of epoxy in there, and I was trying not to cover the wires in case we had to get in there and solder something, but I think it's fine. We have continuity on that, and yeah, just use this 5-minute epoxy, and it's all good. So I think our oh, here's another thing. I don't have any idea what this is. Our 358 oscillator coil. Looks like a rodent chewed on it, but I have not seen any evidence that there were rodents underneath this chassis. So I checked continuity on that, and it seemed to be okay. So I think we're doing pretty well on our level 1 cleanup. I think we're going to flip it up and start making preparations to put the new flyback in. We're going to have to obviously get back underneath here. There's a bunch of solder points we have to get at, so I got to come up with some way to do that. Special modifications to this new old stock flyback. These are the components, and this is the original one that we've taken out, that we've struggled to get going again. Haven't given up on it, but there's things that have to happen. I ordered some parts, so we're just going to use this as a guide, and we're going to make some changes to this, and we're going to put this one in because we're serious about making this set work properly again. And this is what I came up with. So this is the plate cap from the horizontal output tube. It comes to this point here. Goes into a winding in the transformer, but we were able to interrupt that and connect our 47K resistor at that point, and then from that point we snipped off the lead from our focus diode and brought that to here. So we have the horizontal output coming into this point, goes directly into the 47K, into the focus diode, down here to the focus control, and this is a 150 picofarad that is pretty standard, that goes to ground. And there's one other capacitor, a 22 picofarad that I mounted on the back. I think it's totally safe back there. It's not too close to anything. I don't think that point is too close to the ground. I did want to point out, I was really careful. That little eensy-weensy wire that you can see right there coming through the connection point, that goes directly into the transformer. So you can see that that's the size of the lead, and then this particular, where's the other tie point? The other point that goes into the transformer is right there. You can see the little wire there. So I was trying to be as gentle as I could, and it seems to test with the continuity is there. So that's what I did. And maybe we could scoot this insulation down a little bit on this. We're waiting on, I'm a little bit baffled why this is a 27K. This is supposed to be a 68K 2-watt. And even on the design of this particular flyback, the 323, this should, according to the schematic, be a 68K. So I don't know. I don't know what to think about. Anyway, I have another one on order. It's just going to take a few days, maybe a week, to get it. Just a quick note on some of these components that are in here now. These are 2-watt carbon comp resistors. These particular resistors were made by Alan Bradley a long time ago, in the 60s, I suppose. And these are 22 mega ohm, 10% at 2-watt resistors. Now, these particular ones are off value by more than 10%. They're down around 15 or 16 mega ohms. But I just wanted to comment on trying to find 2-watt resistors of a value like this. I mean, I spent a long time searching on the Mauser website, and they have metal film resistors. They have 22 meg resistors, but they only go up to 1 watt. So, I mean, I don't know. You can maybe put 1 watt resistors in here. Maybe it'll be fine. I don't know. But to find 2 watt resistors that are these big values, 22 megs, and in this particular case, it's a 4.7 meg. I mean, I've just had to go to eBay and find vendors that have old stock material. So, not sure what to really think about that, but by the time you add it up, you get in, you place an order for, someone has 2 of these, and you pay $8 for the pair, and then $8 for shipping. Before you know it, you're close to $20 for just 2 resistors. These capacitors, this is a 3 kilovolt. This is a 150 at 6 kilovolt. These are nearly unobtainable capacitors now. They're not made really. So the correct capacitor is a 6 kilovolt at 150 picofarads, and you can find those, but if you look at the number underneath it, that N1500 at 10%, that's the dielectric, the N1500, and the specifications are such that it needs to be much more temperature stable than what the stuff that you can get easily today. You can get 150 picofarad caps at 6 kilovolts, but they're made of a dielectric like a 5ZU or Z5U, excuse me, a Z5U, and they wander all over the place with their temperature. Those are basically caps for safety caps. So there's a lot of these components that really are hard to find. Maybe they're not even made anymore, and so if you find something, you're going to end up having to, well, buy new old stock from somebody or even use from somebody. So I bought one of these. It hasn't arrived yet. It's coming in the mail, and I mean, I guess we're just talking openly about this. I think it was $8 plus $5 shipping. So, you know, one capacitor is going to be, you know, over $10. And it seems like an awful lot, but, you know, my goal here is to rebuild this. So we're going to replace this, and this, and this, and this, and these, and this. We already replaced those. So that's what we're going to do on this one, but not for now. So good luck in your quest for parts. Yeah, I mean, I do spend a lot of time looking for parts when I'm trying to do one of these projects.